Danube project is actually a collaboration project between science and insurance industry and also beyond. And we are looking into the future climate risks in the Danube region. And we try to support insurance industries and also municipalities to get a better understanding of what is the future risk when we think about climate change in the future, when we think about societal change, demographic change. We need to be prepared to take long-term decisions, because the decisions that we take today will last for the next 50 years in terms of technical protection, if you think about that. So therefore it is really important and crucial to have a well-informed decision basis and to take well-informed decisions today.
What we do is really that we produce large event sets of floods and in the end also droughts, heat waves and so on for the entire region, which are of interest for end users from the insurance sector, but also beyond. We talk to city representatives, also to farmers and other stakeholders beyond the insurance sector, and see that there's a huge interest also because there was not much more knowledge in many parts in East and Central Europe, and we really think that we can provide something useful there. And one of the results we see there is that already now we have an increase of risk related to climate change. There's really already a climate change signal in the impacts we have. And this challenges the protection level of buildings and also of critical infrastructure. And the likelihood that really big events happen is much higher possibly than it has been in the past.
As an insurer, there are a couple of things about the project that are very unique and new. So one is that it covers the entire, so for example, from the Danube flood modelling perspective, it covers the entire Danube river network, which is a huge area. And that's something that insurers have not been able to access before. So there have been some models that have modelled partially the length of the river, but not the entire thing. And they're also able to tap into some of the really latest type of modelling, particularly of urban areas. Modelling urban flooding is a completely different type of problem to modelling rural flooding. And you have lots of complications such as drains and underground areas and streets and flood defences in a way that you don't have so much in rural areas. And then the third element is bringing in the concept of climate change. So traditionally, again, most models that are available to insurers do not explicitly quantify the impact of climate change on the risk. So they will be using data that is historical, so the models are based on the average of history, which therefore, by definition, puts you somewhere in the past. Unless you can justify that, unless you can say that your climate is not changing. Now, if your climate is not changing, that is the best way to build your model, but we know that that's not the case. We know climate change is changing. So there are these different versions of the model from a climate time horizon perspective, one which is a historical look at the risk, one which is looking at the current view of the risk, so where are we, what is the risk today and what we would expect for the next few years, and one is a longer term future time horizon. And that's where we can get to, therefore we can quantify the impact of climate change, because you can keep everything else constant. You can keep the urban areas the same, you can keep your exposure the same, and you're basically looking at 3 different points through time, past, current and future, and just looking at that impact on what the flooding risk is and what the impact is on expected losses. So I think there's really 3 very new things that insurers are able to access through this project.
So the future Danube model says something about the flood frequencies and the associated damages with it in the entire Danube basin, and it can say something about flood reoccurrences on a 25-meter grid, and that is fairly detailed down to buildings, really. And so we can ask this model, how exposed is this particular building or zip code or city to flooding, and what will a 100-year flood incur in costs to this area. I mean, we have adapted it a little bit in terms of detail or in terms of resolution and how detailed we represent rivers to the insurance sector to meet the needs of the insurance sector. Because from a scientific point of view, we might not do it at such great detail because we want to say something about larger areas. But yeah, that worked really well, and we're kind of proud of what we have achieved. Yeah.
When we look into the vulnerability aspects, that means that we are looking into different types of objects, like residential buildings or commercial buildings or agriculture or other sectors that are affected by floodwaters, and we try to quantify to which degree these different entities or these different elements are actually damaged. So what is the cost to reconstruct or to rebuild these members after they have been affected by flooding. And in this domain we are facing a lot of problems because we have a huge variability from building to building. We have large scatter and huge uncertainty which we need to consider, and therefore we are proposing in this project some new vulnerability models that look into different factors that are influencing this flood loss. You might think of inundation depth as one driver of flood loss, you might think of inundation duration, but also about the building characteristics. So we need to take into consideration multiple variables to better describe these damaging processes. And in view of the uncertainty that we are facing, we also need to use probabilistic approaches. I think from a scientific perspective, we really moved forward our modeling approaches. So we are now able to consistently model flood losses in a probabilistic framework. This is something that is really new. But I think very satisfactory is also to know that these models are actually applied for certain purposes. So we have given these models also to some partners from the insurance industry who are now willing to run these models for their real-world applications, and there's also interest from public administration and municipalities to apply these models for their real-world problems. And I think this is something that is really satisfactory if you think about, okay, our research now is really solving problems that are huge challenges. So that's something really cool. Yeah.
This is another really interesting thing that we're seeing with OASIS, these types of OASIS projects, is that because OASIS itself, of course, is free to use, so the software that's traditionally been used by insurers is not free. It's actually very, very expensive. But OASIS is completely unique in that it's open source and it's free to use. So we are now seeing that type of software system being able to be used by governments, by cities, by non-commercial entities, because previously they couldn't afford it. So they are now being able to use the types of metrics that insurers use for their decisions.
Our team is actually dealing with the case study within the project, deals with the planning of the new wastewater treatment plant in Novi Sad. Novi Sad is the capital of autonomous province of Vojvodina and the second largest city in Serbia. Novi Sad is unfortunately one of the only two cities along the Danube that doesn't treat its wastewaters. And that is why it is very important to build the new wastewater treatment plant in Novi Sad. The estimated amount of this investment is 70 million euros, and it is very high for the economy of our city and our country. Therefore, the construction of the adequate plant with the possible and necessary adaptation measures in the case of flooding is very important, because our community wouldn't be able to finance the damage caused by the flood events. We have tried to ensure climate change resilience of the large-scale infrastructure by testing how the models developed by our colleagues can be applied in a real world. This is important because there is always a question how the models developed in labs on small scales can represent the behavior of the large-scale objects. Also, we were wondering how we can help the communities, for example, how to identify the risk of climate changes, how to apply possible adaptation measures, how to communicate with local authorities and water management sector in the field of climate changes. So at first they were very, very skeptical because from their pure engineering point of view, they couldn't fully anticipate the importance of ensuring climate change resilience of this investment. The focus of their interest was to build an adequate plant in terms of optimal capacity and optimal technology, taking into account future wastewater generation, population growth in Novi Sad, and economic limits, of course. But after the preliminary results of flood risk modeling, they have realized that they have to include these models and this climate change risk assessment and also possible and necessary adaptation measures in a feasibility study for the future wastewater treatment plant.